Hello everyone, let us see now next point. That is part of de Morris theorem. In last lecture we have already see the statement of the de Morris theorem. That is, if n is any real number, then cos theta plus I sin theta raised to n comes to equals to that n goes to the angle, multiply with the angle. That's it. So cos n theta plus I sin n theta. Let us see some notes depend on that. Notes are: number 1, cos theta minus I sin theta raised to n becomes, again n comes to the angle, irrespective of the middle sign, becomes remains the same. Cos theta plus I sin theta raised to minus n becomes cos of minus n comes to the angle, minus n theta, and we know cos of minus theta is plus cos theta, sin of minus theta is minus sin theta. That's why this minus comes to the middle sign. Again one more, if z is cos theta plus I sin theta, then 1 upon z, its reverse or inverse, is just change the middle sign. Instead of plus, take minus. If it is minus, then reverse becomes plus. Okay. Now if z1 is equal to cos theta plus I sin theta, and z2 is the other complex number, that is cos phi plus I sin phi, then multiplication of these two becomes cos of addition of these angles. Theta plus phi plus I sin, same angle. For cos and sin should be same angle, theta plus phi. And division, if you take division, then the angle become, we have to subtract the angle. Okay. What is the numbers? Number should be, the middle sign of the number should be positive, but while multiplying these two numbers we have to take plus for addition of the angles, and while division of two complex numbers of this such type we have to take subtraction of angles. That's it. Middle sign will be same, plus. Okay, this is for 2. You can extend this for z1, z2, z3, or n number of multiplications or n number of divisions. Okay, next note will be cos of pi by 2 minus theta is reverse sin theta, and sin of pi by 2 minus theta is cos theta. This identity we are going to use frequently in so many examples. Okay, we already seen this identity. Let us see the example. It's the easiest example of de Morris theorem. Simplify. We have to simplify this term. Okay, just simplify. That means we have to make it into single term. Okay, that is numerator is this addition of cos 2 theta plus I sin 2 theta raised to 7. This bracket raised to minus 5 whole divided by this bracket raised to 3, this bracket raised to minus 6. Okay, now we know by de Morris theorem wherever there is cos theta plus I sin theta raised to some number, definitely we are going to use de Morris theorem. Remember that in any example. Now we know by de Morris theorem, first we have to write the de Morris theorem statement. Cos theta plus I sin theta raised to n is equal to cos of n comes to the angle cos n theta plus I sin n theta. Okay, whatever n positive, negative, fraction, irrespective of that, the statement is true for all real number n. Now let us start with the first bracket. Cos 2 theta plus I sin 2 theta raised to 7. We have to make all these brackets into single bracket, same bracket. That's why we have to take the advantage of de Morris theorem, so that what is de Morris theorem says, that number comes to the angle. Similarly, that angles, any number we can take to the indice also. Okay, a reverse statement. Similarly, here we are not going to take this 7 inside. Instead of, we are taking this 2 outside or to the indice using de Morris only. That's why it becomes cos theta plus I sin theta raised to that 2 comes to the indice, and multiply with this 7 we get 14. Okay, that's why we make this bracket simple, cos theta plus I sin theta. Similarly, we have to make all this rest of the brackets as cos theta plus I sin theta. Okay. Now second bracket is cos 3 theta plus I sin 3 theta raised to minus 5. Again this 3 we have to take on index, so we get cos theta plus I sin theta raised to 5 into minus 5 into 3, the minus 15. Now cos 4 theta minus I sin 4 theta raised to 3. Now here minus we have to take also on index, and this 4 also we have to take on the index. That's why it becomes cos theta plus sin I sin theta. This minus comes to index, minus 3 into this 4 becomes minus 12. Okay. Now last bracket cos 5 theta plus I sin 5 theta raised to minus 6 becomes cos this is positive sign itself, we don't need to change it, just take this 5 on the index, we get cos theta plus I sin theta raised to minus 6 into 5, that is minus 30. Now if you observe, all the brackets becomes cos theta plus I sin theta. Okay, now substitute all these values here. What we have, above term means given term, you can say given term becomes, first bracket is this cos theta plus I sin theta raised to 14, second bracket cos theta plus I sin theta raised to minus 15 divided by third bracket cos theta plus I sin theta raised to minus 12, cos theta plus I sin theta raised to minus 30. Now using arithmetic simple procedure, cos the base is same, that's why index gets add, 14 minus 15 becomes addition minus 1. Here also base is same, index minus 12 minus 30 becomes minus 42. Again this base is also same, that's why this denominator comes to numerator as plus 42. Okay, now minus plus 42 minus 1 becomes 41. Cos theta plus I sin theta raised to 41 is our last answer. Again use De Morris theorem, take 41 inside to the angle, we get cos 41 theta plus I sin 41 theta. This is the most simplified answer for this statement or term. Let us see, this is homework for you. This is again same type of homework. Okay, cos theta plus I sin theta raised to 4 into cos theta minus I sin theta raised to minus 2 divided by cos 2 theta minus I sin 2 theta raised to minus 5, cos 4 theta plus I sin, it's take 4 itself, 4 theta raised to 12. Okay, simplify this as earlier, as like this example. And let us move to next example, simplify this. Now this example contains cos theta plus I sin theta. What is statement of De Morris theorem? This one, cos theta plus I sin theta. It is not sin theta plus I cos theta. Reverse is not true. First term should be, real part should be cos theta and imaginary part should be sin theta itself. Here the numerator is okay, cos theta plus I sin theta raised to 4, but denominator contains sin theta first and plus I cos theta. We have to reverse this denominator. That's why it's very important. Start with the denominator itself. Sin theta plus I cos theta raised to 5 is equal to, we know one more term, one more result, cos of pi by 2 minus theta is sin theta, sin of pi by 2 minus theta is cos theta. That's why we have to use this identity here. It becomes sin theta is cos pi by 2 minus theta and cos theta is sin pi by 2 minus theta. Here we have to place this identity here. Rest of the terms raised to 5 as it is. Now it becomes angle, whatever the angle is, doesn't matter. First term should be cos, second term should be sin. Now we can use the De Morris theorem. The applied De Morris theorem here. Everywhere you have to write De Morris theorem. Okay, take 5 inside to the angle. It becomes 5 comes to the angle to multiply to these two terms. We get 5 pi by 2 minus 5 theta, and same for this angle. Okay, now consider this above term which we have to simplify. This term as it is, first term cos theta plus I sin theta raised to 4 as it is, and this term comes to the numerator. Okay, that's why already we have taken 5 inside to the angle, this term comes to the numerator, it becomes reverse, -1, this term as it is. Okay, now what we have to do, see, take again, apply. Here we have already applied De Morris theorem. Here also you have to apply De Morris theorem. Take this 4 inside the angle. We get this cos 4 theta plus I sin 4 theta, and cos of this theta minus I sin of this theta. Now it is not plus here. If it is plus here, we have to add the angle. That is the simple way. But one bracket is plus, other bracket is minus. That's why we can't use that simplification, where this one z1 into z2 is cos addition of this angle only. Okay, but the middle sign of these two complex number is same, positive. Here this is not the term, one bracket is positive, other bracket is negative. That's why we have to apply the second other method, that is we have to simplify. We have to use exponential form, that is e raised to I theta, we know cos theta plus I sin theta. We have to use this statement here. We have to convert this cos 4 theta plus I sin 4 theta as e raised to, instead of theta it is 4 theta, that's why e raised to I 4 theta, into same result for here, e raised to, it is minus sign is there, that's why we know e raised to minus I theta is cos theta minus I sin theta. That's why here minus is there, that's why we have to use minus I theta. What is theta? This angle. That's why it becomes e raised to minus I into this theta. Okay, now it becomes basis same, index should be add. We get e raised to I 4 theta. Addition of this means it is already subtraction, that's why minus as it is 5 by pi by 2 minus 5 theta I. Addition, directly addition as it is with sign. Now take I common, we get 4 theta minus 5 by 2 minus minus plus 5 theta. 5 theta plus 4 theta becomes 9 theta minus 5 pi by 2. Now again use this is a we have just simplify. Okay, now our answer should be in sin and cos. That's why again we have to use this e raised to I, this is theta whole term, this result cos theta plus I sin theta, it becomes cos of this theta plus I sin same angle theta. Okay, now reverse the angle only, because 5 pi by 2, 5 by pi term should be first and angle should be second. That's why reverse the term. For cos, if we reverse the term, the negative doesn't affect on cos. That's why, because cos of minus theta is cos theta, that's why it becomes the same if you reverse the term. But for sine, if we reverse the term, it becomes minus, because sine of minus theta is minus sine theta. This is the most simplified answer for our question. Okay, you can write this as your last answer also. Okay, doesn't matter. Now let us see next. If x plus 1 by x is equal to 2 cos theta, y plus 1 by y is equal to 2 cos phi, z plus 1 by z is equal to 2 cos psi. These are three different angles, three different equations. What we have to prove? These three statements. First one, x into y into z is plus 1 upon x in y into z is equal to 2 cos theta plus phi plus psi. Okay, let us start with the first and rest let us see later on. First we have to find x into y into z. That means we have to separately find out value of x, value of y and value of z from these three given equations. First let us start with finding x. What is the x equation? This one, first one. So, once we find x, other y and z we can write it as similar fashion. Start with x plus 1 by x is equal to 2 cos theta. We have to simplify this or solve this equation. That's why we have to cancel this fraction. To cancel this fraction, multiply throughout by x. Okay, we get x into x, or cross multiply, we get x square plus 1 divided by x is equal to 2 cos theta. Take x on that side, we get x square plus 1 is equal to 2x cos theta. Take this term on this side, we get x square minus 2x cos theta, this plus 1 is equal to 0. Now if you observe, this is a quadratic equation in x. Okay, and for quadratic equation we have formula for finding out the roots of the quadratic equation, that is x is equal to minus b plus minus b square minus 4ac divided by 2a. What is abc here? A is coefficient of x square, that is 1. B is coefficient of x, that is minus 2 cos theta with sign. Okay, and c is last constant term, that is 1. Put this value here in this equation, we get x is equal to minus b, minus minus becomes plus 2 cos theta plus minus b square, that is 4 cos square theta minus 4ac, 4 into 1 into 1, that is 4, whole divided by 2a, 2 into 1, that is 2. Okay, now take 4 outside of this root, it comes out as 2, and this 2 and this 2 comes take common from the numerator and cancel with this 2. What is the remaining term? Cos theta plus minus under root of cos square minus 1, and we know what is cos square minus 1, it is not sine square. Sine square theta plus cos square theta is equal to 1. Okay, this is the identity, but what we want? Cos square minus 1, cos square of minus 1, take 1 on that side, sine square on that side, what it becomes? Cos square theta minus 1 becomes minus sine square theta. It is not plus sine square, it is minus sine square. Okay, now put this value here, we get under root of minus sine square theta. Now take under root of minus 1 and sine square, see, it is like this, under root of minus sine square theta. We can do like this, if root of x into y is there, we can write it as root x into root y, right? Similar way, take minus separate and sine square separate. Well, how it becomes? Minus 1 and sine square theta. Okay, and sine square, root of sine square is root and square root can cancel, sine theta. Now what is root of minus 1? It is a I value. Okay, that's why answer for this is I sine theta. Everywhere you have to make this adjustment. Now this is the root of this equation. Now we have to take only a positive root for our convenience. Let x is equal to cos theta plus I sine theta, and if you observe these equations, y and z both are in similar fashion like x. That's why similarly you can write y is equal to cos phi plus I sine phi, angle is only different, and z is equal to cos psi plus I sine psi. Okay, now in this way we have find out x, y and z values. Now put these values here in LHS side. Let us see what it becomes. Okay, see, x into y into z, this is x, this is y, this is z, and this is one more result. This is multiplication of three complex numbers in with LHS side as these bracket of De Morris theorems, and middle sign all are plus. Okay, angles are different, middle sign is plus, that's why we can use this result. Multiplication of these two is nothing but addition of angles. You can extend this result for 3, 4 and number of brackets. There here 3 brackets are there. That's why just add these three angles. We get cos of theta plus phi plus psi. Middle sign is plus, I into sine theta plus phi plus psi. Okay, this is x into y into z. Now we want 1 upon x into y into z. It becomes 1 upon this total term. And we know one more result. Reverse is only middle sign. We have to take this. If z is cos theta plus I sin theta, 1 upon z becomes only minus. Middle sign becomes change. Okay, that's why it becomes middle sign, angle whatever, but middle sign becomes minus. Instead of plus, it becomes minus. Now we have x into y into z is this term, 1 upon x into y into z is this term. Okay, now if you add these two terms, okay, these two are same but opposite in sign, that's why this cancel, and these two terms are exactly same, it becomes 2 times cos of theta plus phi plus psi. That's it. Okay, now second, this is what we have to prove. Let us see the second bit. This is the second bit we have to prove. X raised to m upon y raised to n. First we have to find x raised to m, then y raised to n, then take the division. And this is the term exactly reverse of this term. Okay, this is y raised to n upon x raised to m. It is reverse of this term. Once we find this term, just take the reverse. Middle sign minus or plus, reverse. Okay, let us start with x raised to m and y raised to n. X raised to n upon y raised to m is equal to, this is x, this is y, raised to m, raised to n. Now apply de Morris theorem, take m inside to the angle, we get cos of m theta plus I sin m theta, and this bracket again apply de Morris theorem, take into the numerator, it becomes cos of n phi plus I sin n phi raised to minus 1. Already n taken inside. Okay, now minus means just middle sign, plus instead of plus we take minus, this bracket as it is. Now again this is one bracket into other bracket, but one plus is one bracket contains plus, other bracket contains minus. That's why we can't use that here, like we cannot do this simplification like this, because everywhere plus is there, but instead here 1 plus 1 minus is there. That's why we have to again use the exponential form, e raised to I theta, that is cos theta plus I sin theta. This is the definition we have to use. Theta is here m theta, and here e raised to minus I theta we have to use, cos theta minus I sin theta. It becomes e raised to I into this angle m theta into e raised to minus I into this angle n theta, using these two results. Now base is same. Once you reduce into exponential, it is very easy to what to simplify. Again you here also, if you forget this result, you can use this exponential part here also, no problem. Okay, now base is same, index should be add, e raised to m theta I minus n theta n phi I, take I common, we get m theta minus n phi. Now again use this result e raised to I theta here, it is the theta value, that's why it becomes cos theta, that is cos of this m theta minus n phi plus I sin same angle. Okay, this is most simplified form of this x raised to m upon x raised to n. The answer should be in cos and sin form, whatever it is. Okay, now just reverse this term, we get y raised to n upon x raised to m, means 1 upon this reverse term here. Reverse means just middle sign, instead of plus it becomes minus, that's it. Okay, now we have to add these two terms. If you observe these two terms, this is plus, this is minus, gets cancelled. This term is 2 times, that's why it becomes 2 times cos of m theta plus a minus n phi. Okay, now third one is also like this, x raised to n into, take multiplication of these two, instead of division you take multiplication, and this term is reverse of this term, and addition of this term you will get this result. This one is homework for you, third one. Okay, let us see next example. If alpha is given 1 plus I, beta is given 1 minus I, and cot theta is given equal to x plus 1, these three are given thing. We have to prove that x plus alpha raised to n minus x plus beta raised to n is equal to 1 bracket alpha minus beta sin n theta into cosec raised to n theta. Okay, now if you see the prove that statement on the LHS side of this statement, you will get what we have to find out first. X plus alpha we have to find out first. Okay, let us start with where x is. It is there in the third equation. Let us start with that. Cot theta is equal to x plus 1. It is given. We know cot. Everywhere de Morris theorem should be applied. That's why in de Morris itself sine and cos is only there. Tan, cot, nothing is there. That's why once cot or tan is there, we have to convert it into sine and cos. That's why cot theta we know cos upon sine is equal to x plus 1. Therefore x becomes cos theta upon sine theta. This one comes to this side minus 1. This is x value. Okay, once we get x value, again for simplification on RHS side alpha minus beta, just make this calculation. Alpha minus beta becomes alpha is 1 plus I minus 1 minus I. Okay, remove the bracket, we get 1 plus I minus 1 minus minus plus I. 1 gets cancelled, I plus I 2I. Alpha minus beta value becomes here 2I. Okay, you can do this calculation after at the end whenever required. Okay, now once we get x, we have to start with this term x plus alpha. We have to find out and then raise to n. Wherever power is there, we have to apply de Morris theorem, and wherever de Morris theorem is there, sine cos is there. That's it. This is the logic. Now x plus alpha, let's just find out first. X is value this plus alpha value is 1 plus I. 1 gets cancelled, it becomes cos theta upon sine theta plus this I. Now take cross multiplication, we get cos theta plus I sine theta divided by sine theta. This is x plus alpha. We have calculated. Simplify. Now in similar way calculate x plus beta. This is x plus beta calculation. Answer is cos theta minus I sine theta raised to upon sine theta. Okay. Now consider LHS side of the prove that statement. LHS is x plus alpha raised to n minus x plus beta raised to n. This raised to n minus this raised to n. Okay. If you see the denominator is same, raised to n is there. Take the common denominator, sine raised to this n goes to so same numerator and denominator both, sine raised to n theta. Base is same, that's why we are combining these two terms. Now it numerator of first term becomes cos theta plus I sine theta raised to n minus middle sign cos theta minus I sine theta raised to n. Again apply de Morris theorem. Wherever we are applying de Morris theorem, you have to write. Now take a n inside this bracket, we get cos n theta plus I sin n theta minus bracket cos n theta minus I sin n theta. Now remove the order brackets, we get cos n theta minus cos n theta gets cancelled. I sin n theta minus minus plus I sin n theta becomes add, and it becomes 2I sin n theta divided by sin raised to n theta as it is. Now this is our answer, simplified answer for LHS side. But what is on RHS side? We have to prove alpha minus beta sin n theta is there. It is okay. But here cosec raised to n theta is there, and we know a reverse of sine. A sine is in the denominator. If it comes to numerator, it becomes cosec. Reverse of sine is cosec raised to power is same n theta. Okay, 1 upon sine is cosec. Power is not comes to the denominator. Okay, numerator. 1 upon sine becomes cosec. Power is same n theta. And here 2I, instead of 2I we can write alpha minus beta here, because we already calculate alpha minus beta value here. That's why instead of 2I write down alpha minus beta, this sin n theta as it is, and cosec is to n theta. This is our required RHS side. Okay.